This is Note-Taking Guide 4.5, Solving Systems of Equations by Graphing. When we graph two equations, we have three things that can happen. The first thing that can happen is that we have one solution. If we have one solution, our answer is going to be in the form of an ordered pair with an x, y value for our solution. And if we're going to look at that on a graph, it's going to have two intersecting lines. And you're going to be able to find that intersection and label it as an ordered pair. So right here where they both intersect. The second thing that can happen is that we're going to have no solutions or zero solutions. When we say no solution, we have a math symbol that will describe that, and it's called the empty set. It's a zero with a line through it. If we have no solutions, that's when we have two lines that are parallel to each other and they will never cross or intersect. Again, that's no solutions. The last thing that can happen is we have many solutions. We like to call that all real numbers or infinitely many solutions. That uppercase cursive R stands for all real numbers. And when that happens, we actually have the same line right on top of itself twice. So if we graph our equation and we get that first line, then we graph our second equation and we get the exact same line again, that's every single point is a solution to the set of equations, and so all real numbers would be our solution. So what we're going to do now is we're going to look at each of these graphs and tell how many solutions they have. So because these two lines intersect in one exact solution here, we know that they have one solution, and we know that we can write that ordered pair. So we went over 3 and up 5 from the origin. So our ordered pair and point of intersection would be 3, 5. This next example here, we have two parallel lines. These parallel lines are never going to intersect with each other, so we know we have no solution. And if you remember what I said no solution is represented by in mathematics, it's that circle with the line through it is called the empty set. It means no solution. So what we're going to do now is we're going to graph our lines ourselves and see if we can find our point of intersection. So this line right here is already in y equals mx plus b form, so that we know that we have our slope, which is our m value, and we have our y-intercept, which is our b value. Our y-intercept tells us where our graph touches or crosses the y-axis, and it's our starting point. And then we follow our slope, which is our rise over our run. So on this line, it tells us to start up at 3 on the y-axis. So you're going to go up at 3 and just draw a little point. Then you're going to follow your slope. Your slope is 2, so we're going to write that 2 over 1. So from there, you go up 2 units and over 1 unit and draw another point. Your line's going to go through those two ordered pairs, and just do the best that you can to make sure that your line goes through those ordered pairs. Our next line here that we're going to draw has a y-intercept of 2, so we're going to start up at 2, which is right here, and then follow our slope, which is 1, because the number out in front of the x there is 1. So up 1 and over 1, up 1 and over 1, up 1 and over 1. If you're going up 1 and over 1 and you want to go the opposite direction, you could go down 1, left 1. And you're going to draw your graph through those ordered pairs. You can see here that we have one solution, and I can tell the ordered pair that is. My ordered pair would be -1, +1 as my point of intersection. And that point of intersection is right here. All right, here's another example of the exact same thing. These equations again are already in y equals mx plus b form for us. So all we have to do is start graphing them. The 5 is where my y-intercept is at, so I'm going to go up to 5 on my y-axis and draw an ordered pair. Then I'm going to follow my slope, which is 1 over 2. So up 1, over 2, draw a point. So again, I'm kind of heading up off my graph paper over here, so I want to do one more point, which would be down 1, right 2 over here, just to kind of give myself a better idea of the direction my line's going. So my line's going through those ordered pairs. I'm going to graph my second equation by doing the same thing. So the number that's added back behind here is 0. There's nothing there. So I'm going to start at 0 for my ordered pair. And then I'm going to follow my slope. My slope is a negative 2 over 1, which means down 2, right 1, down 2, right 1. Now when I'm graphing these lines, and I know I'm looking for a point of intersection if there is one, I like to follow my slope the opposite direction if I can until I find that point of intersection. So if I went down 2 and right 1, I'm going to go up 2 and left 1, up 2 and left 1 until I find that point of intersection. Draw your line through those ordered pairs, and then this point of intersection right here is the ordered pair that is our solution. So that ordered pair for our one solution is represented by negative 2, positive 4. All right, this next example here is a checkpoint. So if you'll pause the video right here and try this one on your own, then I will do it for you and you can check your work. Okay, so our y-intercept on this is 1, so we go up 1 and draw an ordered pair. Then our slope is a negative 3, so it's going to be negative 3 over 1, so down 3, right 1. So we go down 3 and right 1 from that point, and then our ordered pair will go through those points. I didn't do a very good job hitting my ordered pairs there. But let's try on our next equation. Our next equation, we're going to start at negative 3 on our y-axis. And from there, we're going to follow our slope. Our slope is the number in front of the x. The x has the number 1 in front of it. So my slope will be up 1, right 1, up 1, right 1. So my graph goes through right here. Now again, remember my green line didn't go exactly where it was supposed to, but you can see my little ordered pair mark right there to show me that point of intersection. So again, this has one solution, and my solution is 1 and negative 2 for the point of intersection. Okay, again, pause the video right here and try this one on your own to make sure that you remember how to graph these. Alright, I'm going to start at positive 3 on the y-axis and then follow my slope, which is up 1 over 1. So my line's coming through those ordered pairs right there. Then I'm going to start at positive 1, which is right here, and I'm going to go up 3 and over 1 to graph that. My point of intersection is right there, so I have the answer 1, 4. As the solution to my system of equations. All right, we have a couple more examples here to go and then we're done. These ones are not solved for y, so they're not in slope y-intercept form. So we know we have to solve them for y first. So I'm just going to rewrite this one over here, the 8x minus 4y equals 16. And I'm going to solve this for y. So I've told you to just kind of cover it up, and you need to cover up that 4y and see what you need to move. When you cover up the 4y, you need to get rid of the 8. So we're going to take that 8 and we're going to subtract it over to the other side. When we subtract that 8x over to the other side, it doesn't combine together with that. It just gets rewritten. So we'll have a minus 8x and a plus 16. We're going to divide both sides by negative 4. To get y by itself, and when I do that I have to divide everything by a negative 4, And then everything on this side cancels to just y. And then on the other side, negative 8 divided by negative 4 is a positive 2, so positive 2x. And 16 divided by negative 4 is a negative 4. So my first equation there is ready to graph. I'm going to start down at negative 4 from my y-intercept, and then follow my slope, which is 2 over 1. So up 2 over 1, up 2 over 1. And my line goes through those points of intersection right there. All right, we're going to solve the other equation and then graph it. I'm going to rewrite it over on this other side right here. So I'm going to have a negative 5x minus 5y equals 5, and I'm going to solve this for y in order to graph it. So add the 5x over to the other side, and I get a negative 5y equals 5x plus 5. I'm going to divide everything by a negative 5. Cancels over here, and I get y equals negative 1x minus 1. So I am going to start at negative 1, which is right here, and to go down 1, right 1, down 1, right 1. And you can see your point of intersection as you draw those ordered pairs. Our point of intersection is right here. And that ordered pair would be 1, negative 2. All right, on this last example, the second one's ready to graph. So I'm just going to start and graph that one. Then I'm going to fix that top one in order to graph it. So I'm going to start up at 3 and then follow my slope, which is 1. So up 1 over 1, up 1 over 1. So my line's going through those ordered pairs. Then that second equation, I actually need to solve it before I can graph it. So I have 2x plus 2y equals 6. And I'm solving it for y. So I'm going to subtract the 2x over to the other side. And I get 2y equals negative 2x plus 6. Divide both sides by 2, which means everything gets divided by 2. It cancels on this side to y. I have a negative 1x here and a plus 3 there. So this is my y-intercept. I'm starting up at 3, which is right there. There's a point of intersection. I go down 1, right 1 to get my graph. And that point of intersection is actually my solution. So my solution is the ordered pair 0, 3. All right, guys, now you're ready to do your worksheet.